Today I want to focus on chapter 5 and 6, tips and tricks. Chapter 5 is on continuous distribution functions, continuous random variables, and chapter 6 introduces us to the most important continuous random variable, which is the normal distribution. A normally distributed random variable has this bell-shaped curve, and in statistics, we know that something that has a bell-shaped curve follows this equation here. It's called the Gaussian distribution. It has a pi in it, it has a sigma, has a mean, it has Euler's number, that E there. It's a very complicated formula that we wouldn't be able to use unless we understood calculus and higher levels calculus. I'm not going to make you use that. Some of your previous instructors might have had you use tables and z-scores. I'm not going to use that method as well. I'm going to stick to technology like StatCrunch or the free app. So if you've seen this before, you know that a normal distribution, one way to define it is that by the mean and the standard deviation, that all of the data is within a certain number of standard deviations from the mean. So you see 1 standard deviation, 2 standard deviations, 3 standard deviations. So we're going to use that definition, which we call the empirical rule, and look for 68% of the data within a certain distance from the mean, 95% of the data within a certain distance of the mean, and 99.7% data. So the empirical rule tells us that 68% of the data, the mean is the center, since this is symmetric, the mean is the center. So if students on average spend $210 with a standard deviation of $38 on textbooks each semester, and it's normally distributed, how would that look? Well, 210 would be right here in the middle. And then out from that, if I go 1 unit on either side of that, would be, I'm going to add 38 to go to this side, so that's 248. I'm going to subtract 38. I'm going to subtract 38 to go to the other side. And so I see if I type in 210 and 38, and I click on compute, and I click on this right here, it will do the math for me, 172. So we can see right here, 172 on the lower side. Another standard deviation out is 286 and 324. Again, that's just another 38 units on either side. And on this side, if I go down 2 standard deviations, I see that's 172 and then 134 and 96. And so I could tell this is a normal distribution if approximately 68% of students spend between $172 and $248. Okay, so if that is true, I also know that 95% of students spend $134 to $286. And that's what we consider the interval of normal values, of usual values. So anything outside of that would be considered unusual. And so these are extreme values. We have 99.7% of students spend between $96 on textbooks and $324. Somewhere in that wide interval. Okay, and so that's our definition of a normality. That's what normal tells us. This is true for any normal distribution. So if I change the values, and I go to another college, let's say it's a private university and the average is $318 and the standard deviation is $48, then I know that 68% spend between these two values, 270, 366, 95% spend between here and here, and 99.7% spend between here and $462. So that's true for any normal distribution. No matter how I change the center and the spread, that 68, 95, 99.7% stays true. The second thing I want you to know is how to calculate probabilities using the normal distribution. So if I wanted to calculate probabilities, what is the probability that a randomly selected student spends more than $240? More than $240. So I'm going to use this and type in, again, let's assume that it's the same college where students spend $210 and $38 standard deviation. And I want to find the probability that they spend more than $240. Okay. Then I'm going to type into the normal distribution app that the mean is 210. The standard deviation was 38. And the probability that I spend more than $240, or a randomly selected student spends more than $240, I'm going to hit compute. And I see that that probability is 0.2149. Okay, and then I can also, the next question asks me, what's the probability that they spend less than $200? So less than $200, I'm going to go here and change this to less than $200. And because it's continuous, it doesn't matter if it's less than or equal to. I'll get the same answer either way. That's why there's no option for that on this distribution. I hit compute, and I get less than $200 is 0.3962. If I want to do between, I select up here. So there's an option right up here for between, and I type in between $200 and $240. And I find that the probability is 0.3889. Okay. Now, what is the cutoff for the lowest 15%? So I'm going to change this back to standard. And I want to figure out how to make this red area 15% over here. Red area 15%. So I'm going to go over here, and I'm going to keep that as less than because I want it lower. And I'm going to make this 15%, but I'm going to type it in as a decimal, 0.15. And I'm going to hit compute, and it will fill in the missing number, the cutoff value. So to make this 15%, I'm going to use the probability that x is less than or equal to what equals 0.15, and I see that that is $170. Make sure you put the units on it. $170.62. Any student who spends $170.62 or less will be in the bottom 15% of students. Is it unusual for a student to have spent $105 on class supplies? So 105, we see, if we look at this right here, 105 would be outside 2 standard deviations. So 105 seems like it's a small amount. Is it unusually small? So I'm going to keep this as 105, and I hit compute, and I see that the probability is less than 5%. So Yes, it is unusual because $105 is more than 2 standard deviations below the mean. So this is a probability. This is a probability. This is a probability. When they give me a probability, or a percent in this case, I need to find a dollar amount. So that's a dollar amount. And this is using this graph up here. Anything outside of 2 standard deviations away, anything outside of the shaded area, anything in the tails here or here would be considered an outlier because of the empirical rule. More than 2 standard deviations happen less than 5% of the time. All right. So that's just chapter 5, tips and tricks. We're going to be using the normal distribution throughout the rest of the class, but that's what I kind of expect you to know for this first exam.